Now we are going to talk about some rules of differentiation. Like rule 1 is for differentiation of functions with addition. You can call this rule to be like addition rule or subtraction rule. For example, let's say we have a function y is equal to sin x plus cos x plus x square. And if somebody asks you to differentiate a function, then for differentiation of sin x, you write cos x plus differentiation of cos x is simply minus sin x, and for x square it is 2x. So simply what you have to do is you have to simply differentiate the function and write the corresponding signs. If positive sign is there, then you have to replace the positive sign as it is, and if there would have been some negative sign, then you would have replaced simply negative sign. If it is positive, replace positive, negative, replace negative as it is, and differentiate each part of the function. That is why I have named it to be addition rule, that you have to differentiate each part in addition and then you'll get the result. Rule 2 is rule for, or you can say rule for constant multiple. Constant multiple, right? Like y is equal to, let's say, 3 sine x. If you have to differentiate it, then what you'll do is you'll just keep the constant number as it is, and you'll simply differentiate sine x as cos x. So, or we can say, for example, if y is equal to 5x square is given, it simply differentiate 5x square as 5 as it is, and for differentiation of x square is simply 2x. So you get 10x is the result. So what I did here, I just kept this 5 constant as it is, right? So these are the two rules used for addition of various terms involving x, and this is a rule where some constant is multiplied with some function of x, right? So in fact, uh, for rule 3, we see that rule 3 is called multiplication rule. For example, let's say we have two functions u and v. What you have to do is you have to simply name any function to be first and the other one to be second. For example, let's say if I am given two different functions involving x, like let's say e to the power x and sine x, then I'll have to name them 1 and 2. Any function can be named as 1. Let's say this is 1, this is 2. So I write it as sine x, then e to the power x. Now if I have to differentiate this, then what I'll do is differentiation of multiplication of two functions is simply given as first function as it is, keep the first function as it is without any differentiation or anything else. First function as it is, differentiation of second plus keep the second function as it is and put or multiply the differentiation of first function. So keep the function first function as it is, differentiate second function and multiply it with first function. Put positive sign. Keep the second function as it is. Now differentiate first function and multiply it with the second function, which was kept as it is. So in this example, we put sin x to be first function and e to the power x to be the second function. So what I get here, first function sin x as it is, second function e to the power x, differentiation of e to the power x is e to the power x itself. We putting plus sign. Now I keep second function as it is and differentiate second first function, that is differentiation of sin x is simply nonsense. Let's see some other example, like y is equal to x square into sin x. So here dy by dx, that is the differentiation of this y with respect to x, is first function. Let's say this is first function, this is the second one. So I kept x square as it is, differentiation of sin x is cos x plus sin x as it is, and differentiation of x square is 2x. So your answer is simply x square cos x plus 2x sin x. This is dy by dx. So this time it is your answer. So this way you can differentiate any function, any complex function which is a multiple of two different subfunctions of x. Right, let's see some more examples. We are given something, let's say like a to the power x into e to the power x. What I do is I'll put it as first, this one as second. Now dy by dx is equal to first function as it is, differentiation of second function is e to the power x plus e to the power x as it is, and differentiation to a to the power x is a to the power x ln a. This is the answer. So this way we can differentiate any function which is having two different multiples of functions, right? Let's see some more examples. Like if somebody asks me to differentiate y is equal to 1 by root 2 x, then to differentiate this function, what I'll do is I'll just keep 1 by root 2 as it is, and 1 by root x is this. Now 1 by root 2 as it is, and root x is simply x to the power half, and then x to the power half is taken in numerator and divided as like this. Now I used the function or the differentiation of x to the power minus half as minus half x to the power minus half minus 1, right? So differentiation is, you can see 1 by 2 root 2 with minus sign, right? And x to the power minus 3 by 2, which is when taken in denominator can be written as x to the power plus 3 by 2, or you can simply write it as 1 by 2 root 2 x root x. So this is the answer for the differentiation of 1 by root 2 x. X is in the root itself and 2 is also in the underneath, right? So this way we can differentiate any function. Let's take some more examples. If somebody asks you to differentiate, let's say y is equal to 3 to the power 2x. Now what you'll do is simply you will write 3 to the power 2 as 9x, 9 to the power x. Now let's write it here. Now it is in the form a to the power x, and a to the power x can be differentiated as a to the power x ln a. Very simple, right? Let's take a couple of more examples. If I ask you find value of x at which derivative of y is equal to x minus 2 whole square is 0. Now we are asked to find the value of x where the derivative stands for differentiation, right? Derivative means differentiation of the given function. Now I'm asked to find the value of x where the differentiation, that is derivative of this function, is 0. So what I'll have to do is I'll have to simply differentiate the function y is equal to x square plus 4 minus 4x. Now differentiation is dy by dx is equal to 2x minus 4. And now I'm just required to put that equal to 0 to get x is equal to 4 by 2, that is 2. So this is my answer for this question. So if somebody asks you to find the derivative also means you have to find the differentiation of the function. So in this video we learned three rules. A rule for addition of two different parts of x, like y is equal to sin x plus cos x plus e to the power x or something like that. In the second rule, we learned the rule for constant multiple, like if somebody asks you to differentiate y is equal to 5 sin x, then you keep 5 alive as it is, and you simply differentiate the part which is containing x, that is 5 sin x is differentiated as 5 cos x, 5 kept as it is, and sin x is differentiated to cos x, right? In third rule, we learned how to differentiate a function having two simple parts of x in multiplication, right? Like y is equal to sin x into cos x, or y is equal to x square into sin x. So here in x square into sin x, we have two functions, x square and sin x. We have two functions, x square and sin x. So this sub function of x is named as 1, this as 2. Now what I do is I keep first function as it is, differentiate second function. Now I keep second function as it is and differentiate first function. So this way I can easily find the differentiation of functions having two small functions of x and multiplication. So up to this video we have learned these three rules. Now next video will be dealing with the division rule when two functions are in division, right? And fourth video. And in fifth video, we'll be dealing with the chain rule, which is actually very important and a bit tough also.